All right, so you guys are already a little bit familiar with different functions that are in Python. For example, print, input, the len function, etc., to calculate the length of things. A function itself is kind of like a little mini program within a program. So you guys are going to be writing little code blocks that you can then call multiple times over and over. Some of you might have already seen it in your homework. You may be repeating yourself multiple times to run the same little bit of code. And what we want to do is try to minimize the amount of code that we have written in Python. And to do that, one of the ways is to use functions. So the idea is that if we look at this function here, we have def hello, in which we are defining the function called hello. You'll notice it needs 2 parentheses at the end and then a colon. And then in the indented space, we tell it what we want to run in this little mini program. So for example, this one's going to print howdy, howdy, and a hello there. And then anytime in our program, we can call the function hello, and it's going to run this code. Therefore, if we ran this, hello, 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 it's going to do this function 3 times. All right. That one's pretty meaningless, but there's other calculations that we may be doing. So for example, you guys worked with age and a couple of other things in your homework assignments. We may have a function that will calculate a bunch of different ages, and it's something that's going to happen over and over. We may want to write a function for that to happen. All right. To set up a def statement, again, you'll have the def keyword up here at the top. You'll have the program name. Now, typically, we could have things called arguments, in which case we're going to pass something into the function in order to do the calculation on that. So in this case, in the outer program, we're going to collect a name. When we collect that name, we're going to pass it into the hello function, in which case we can then reference that function inside of, or reference that argument inside of this function. So in this case, if we look up a little bit of code here, we would start off with something like hello. And in this case, we're going to pass a name in there. We would say print hello plus like this. And then down below here, we always set our functions up at the top of the program, right? So you'll have your initial comments, you'll have your imports. The next is going to be all the functions that you define. From there, we can actually start our main program. So we can say print hello and welcome to Python. Print what is your name? In which case we would have name equals input. Again, we can clean up our input a little bit here. And then we need to call our hello function. So it'll be hello, and we're going to pass in this name variable up to the top. Now notice in this case, these happen to have the same variable name. We can also call this something else. So we could call this something like first name. And then here we're going to pass in first name into the function. Once we pass that into the function, it is now referenced as name. Therefore, inside of our function, we just use the word name. All right. That is the difference between local variables and global variables. We're going to get into that a little bit more here in detail. For simplicity, we're just going to go with name for now. And if we run this little program, you'll see that it's going to start the code after the defined function, because this is technically the first line of code that will get executed. It runs through here, it prints out our message, it asks for our name, I type in Jason. At that point, it's going to call this function and run this code inside of here. All right. Again, right now it's pretty basic, but this is the only time where Python does not necessarily go from top down. It does, it starts here is its top, in which case it'll bounce up here, execute this code, and then continue on down. So if I have something like print goodbye, it would actually go ahead down to the next line of code after that function is ran and print goodbye down at the bottom. Right. Again, typically we would do functions to either one, just kind of subcategorize our program. So if we need to break things up into multiple sections, that is a good use of functions. Another good use of functions is to reduce the duplication that you have inside your program. So if you have a huge chain of if statements that is checking for every little thing in there, and it's going to do something based on whatever that long if statement was, we could probably rewrite that in a way to do it with a very small function and just call that function with a new variable every time. All right. So again, we define what this function is called. It uses the same functionality of making sure you use camel case. I strongly encourage you not to use capital letters at the beginning. Yes, it will work, but again, that is reserved for classes, which we'll learn at the end of the semester. And we don't want to get those too confused. So it's much better to always start with the lowercase when you're working over here with functions. Same way with variable names. I've seen that in some of your homework where you use a capital letter to start. Yes, it will work, but it will cause you problems down the road. Don't do that. All right. So this is the definition that we're setting up. We're going to pass in this argument, all right, in which case the parameter is then used inside of here to do whatever with. In this case, we're just printing it back out. So down here below, we're going to call that function and pass in something in here, whether it's something we input or maybe it's something that we're passing in as a defined string. All right. In a function, we have the option of using a return keyword. So this can be either a value or an expression that the function would end up returning, meaning that if we look at this function here, right now, we don't return anything. So if we don't have return defined here, it is just going to return none, which means nothing happens when we return it down here. We could, however, return this as a string. So if we say my string equals hello, and we return my string, if we actually run this, you'll notice it'll ask for the name, but it immediately goes to goodbye. Notice it did not print the string inside of here. Instead, what it did was built out a string that we would then have to put inside of a print function. So we would have to say print. And now down below here, it would go ahead and print out that name inside of that. Notice that I'm calling the print function. Inside of the print function, I'm calling the hello function, and I'm passing in the name variable that I typed in before. So you can call functions within functions in order to get an outputted variable. It always runs the inner one first. Think inside parentheses, just like we did with math operators, it would run that code. Now, why would we return a string versus just printing it out inside the function? There may be something that we need to massage that string later on. Maybe we need to edit it. We need to just pull out a certain set of it. Or maybe we're just returning a number back out of here that we are then going to do something else with that downside inside of our program. That is the reason you have this return option. And in this case, we tell it to return whatever came out of my string. We could also return something like true, or we could return false, in which case we could do a test down here and say if name, in this case, if hello name equals true, then run some kind of code here, else run some other code down here, right? So if we were testing to make sure this name had at least 4 characters, for example, we could say if the len, which is the linked function, of name is greater than 4, then return true, else return false. We're going to rename this function to calculate name. And so now what we're going to do is test to see if this length of whatever they type in is greater than 4. If so, we do true. If not, return false. So this would help us build something like, let's go back from a name and let's do a password, right? So now we're going to type in a password. And what we want to do is make sure that the password that they're setting is generally greater than, say, 8 characters, or we're going to say greater than or equal to 8 characters. In this case, we're going to change out our function and use calc calculate password. And if it's true, we're going to say print that is a valid password. And if it's else, we could print that is not a valid password. The link must be at least 8 characters. Okay. All right. So if we're bringing in passwords, this is great. It's going to print us out and tell us whether it's valid. It's also going to tell us whether it's invalid. It would be nice to put this inside of a while loop so that if it's invalid, we would keep them in the loop until they have a valid password. So to do that, we use our while loops that we learned last week. So we would do something like while true. We would go ahead and print and grab the password from them. We indent this all over here. And in which case we need to put a what after this if that password is valid. A break, right? That gets us out of this while loop so that if they are a valid password, we go ahead and continue down below here. All right. So if we run this little function in our program, we got one messed up. There we go. So calculate password, we're going to type in our password. And so now it wants to know our password. If I type in we'll get back a response that that's invalid and that the length of the characters must be 8. If we type in Jason, that's 5 characters, and we say the length must be 8. We type in Fort Hays State University, we end up with a valid password. All right? Does everybody kind of see what the purpose of this is? Now, this just goes up and calculates the password, but we may have a different program here in which we're inputting a bunch of users and a bunch of passwords, in which case we could call calculate password every time we get a password in from a user. So right now I'm just checking one user, but if I am starting to store this information in the list, which we'll learn about next week, we could then grab the information from every user and their password, and we could run these individual functions on each one to make sure it's valid. This one calculates a password. We may want to go through and do a check of, does it have a special character? Does it have a capital letter? Does it have a lowercase letter? We could write out those individual functions to check for that. All right. Anybody have any questions on that? All right. Again, by default, a function will return none, meaning that it returns a non-type variable. Nothing's going to come back out of it. So you can either print something inside your function if you want to, or you could return a string and print that using your main program down below. Either way is acceptable. There's reasons to do both. Okay. We talked a little bit about the non-value. This non-value is basically the absence of any kind of value that's inside of it, meaning that if we say print something out or return something of none, then it ends up being none. All right. Most of you have used the print function so far. Right now, we're just using it to print something like a string. So for example, we have print goodbye, right? When we do print goodbye, you're going to see it each on their own line like this, right? At the end, what's really happening is we are printing something with a /n, which is saying that we want to put a new line immediately after this print. And so inside of a print function, there is the first part of whatever you want to print. And then there is an argument called end in which we can specify what we want this sentence to end with. By default, that is a /n, meaning that it's a new line. So if we print and run this real quick, you'll see that we see this /n at the bottom, and it actually added that to the end of this, right? It's actually the other direction. Notice how it just returned off the line there, right? We could tell it to end in whatever we want. So if we want to end this in Go Tigers at the end of the line, we would see Go Tigers gets added to the end of the line. Now that's not as beneficial, but we may want to end that in something in particular, and therefore we can specify what goes here. However, if we do something like this, in which we have a print statement immediately after that, notice that it printed by and it ended with Go Tigers, but because there's no new line character at the end of this anymore, it actually prints out the next line immediately after it. So if we did something like this, Go Tigers, to go after every line, we would want that /n in there in order to create that new line so that the next print statement prints out on the next line. All right. So end is an option for the print statement where you can specify what you want it to be. You may want it to print absolutely nothing, meaning that it's going to end up joining all of these together, in which case we would just print end with an empty string, no space in it, and then the next line would print immediately after that. Or if we wanted just a space, we could put a space there. Okay. Print will also take multiple arguments, meaning that we could have print goodbye, we could have dog, we could have cat. And if we print this all together, notice that we get goodbye with a space, then dog, space, and then cat. All right. So you can pass in multiple things into the print function. It will print them out with a space in between each one of them. Okay. If you wanted to define what that separator would be, meaning right now by default the separator is set to a space, we may want to use the set variable and set that to whatever we want. So say we want to separate this with asterisk. We could then use this line, in which case it will separate each one of these variables that we passed in with an asterisk inside of it. So we could use a space, we could use a comma, we could use whatever we wanted. Comma was probably the most helpful. That's going to build you out something that's comma separated, which is a little bit like something that you could maybe use in Excel, or maybe you could use it to chop things up later on based on that separator. All right. Does anybody have any questions on end and the separator arguments? Okay. So when we do a call stack here, really what's happening is they're kind of talking like where Alice is talking, then Bob will go and get talked, then it go to Alice, in this case, Carol, all the way to the top. Then it goes back to Bob, then to Alice, and that. What happens with this is when you call multiple functions within a function, this is where it can get a little dangerous and you have to be careful. So for example, if we look at this code, we have A as a function up above here, and it's going to say print A starts, then it's calling B, in which case it goes to B down here. Then it's going to call D after that. Then it's going to return and say A returns. So if we look at this, it goes from A to B, comes down here, executes code, which then calls C, goes down here and executes this code, goes all the way back up into this function to call D, prints these two lines, then goes down and says A returns. Meaning that these functions will continue running each line. If it gets called to another function, it'll run all the lines in that function, then go back to the original function and continue on down the line. Which means the output is going to look something like this. Now, a lot of times where you'll run into this issue is instead of using a while true loop for like say a main menu in your function or your program that you're running, students will put everything out in little functions and then they'll just recall the main function. If you do that, you're going to end up in this weird loop, in which case if you got wrong input or cancel out of that function, it's going to send you all the way back down the stack into where you originally started. So try not to call functions within functions that then go into other functions. Try to keep it to like a 2-function minimum and never call the same function within the same function. If you wanted to start back over from the top, use a while true inside of there. In other words, if I need A to run and I get down here to the bottom and whatever you typed in the middle didn't equal it right, I don't say run A again inside the same function. I just use a while true up here and let it do a continue and start back over. It's a much better way of doing it. It will save you a lot of headache trying to figure out why your program's acting weird. Does anybody have any questions about calling functions within functions? Y'all came out as Python geniuses today. I love it. We'll find out on Thursday or Wednesday. All right. The next topic, which is a little hard for some people to understand, is local scope and global scope. All right. When I am working with my program here, this variable of password that I'm creating with my input is considered to be in the global scope. It's in the main program on the outside. If I'm on this inside, for example, we call this password. We're going to now call this my password. And I'm going to pass that into this function. At the point it goes inside this function, it is now called password, not my password. All right. So for other words, if I say I have password inside of here, and I say password now equals password plus something else, then I can return true, just for the sake of this program. If I come through here and I have them type in the password, we could say something like print, you typed my password, right? That will print out what they typed. When they get up here above, it's going to get something else, in which case this time we're going to print password. And we're going to print my password. And to give that some context, we will print this is the password inside the function. And this is the original password you typed. Go. So if we look at what this is doing, we're taking this variable of my password, we're setting that inside the global scope. Then we're going to pass that into this calculate password function, which we see here. Note when we call this, we are passing in whatever variable. When it gets up into this function, we are now assigning that to the variable password, in which case we're going to take that password and add the string something else to the end of it. And then we're going to print out that new password, but we can still print out the original password by going out and grabbing that variable from the global scope. So if we run
Hello. Where are you at, bro?
What do you mean?
What's up?
Why'd you call me?
Hey Chase, you're on microphone, bud. Okay. All right. So we've got a new password. We type something in like Fort Hays State. And we can see here that we typed in Fort Hays State. That was our original password that's up here, right? That's this line being printed out. Let me get these side by side so we can see this. I gotta bring this one up a little bit. There we go. Then we have it printing, this is the password inside of the function, in which case we have Fort Hays State, but we tacked on something else to the end of it, as we can see here. We can still call the original password, which is Fort Hays State, down here, and then it goes on through the rest of the program that we had. So again, the global variable in this case is the my password. Once we pass that into this function, we have the local password here. We can reference the global password, but we cannot change that password. So if I say something like my password equals butterfly, okay. Then if we print my password, it will be there after this function runs, which in this case, we're just going to take this stuff out for now. And we're going to call calculate word my password print. Here is the password after the function. In which case we are going to add this my password back here. So if we run this code, We step through it. We set a password, which is what we're doing here. Again, this is getting assigned my password in the global scape. So we're going to say dog. And we'll notice that we get an error here. Cannot access the local variable my password as it's not assigned with the value. So when I try to print that here on line 6, I cannot access my password that is out here when I try to set this variable called my password here. The moment I try to define my password, which is what this was in the outside scope, this became a local variable. All right, meaning I can modify it all I want inside of this function. For example, if I say my password is now butterfly, and then I attempt to print that, so I switch these two around, and I say dog. Try this again here, dog. All right, so now I have U type dog, which is this line, right? Then we're going to run our function in which we can pass dog in here. Now I have a password where we did dog plus something else, right? That's what we see over here, dog, something else. The original password that we typed in the scope, first we specified that to be my password is now equal to butterfly. We print that, we get butterfly. However, after this function is now done running, we go back out to the global scope. Notice that we printed out, here is your password after the function, and that password is dog. Meaning this my password that we defined inside of our program in here is not the same as the password that's on the outside. All right. If we're just going to call it and reference what it was, we can just call my password. But the moment I try to define it inside my local scope, inside my function, it doesn't overwrite the outside one. It just defines a new one that only runs inside that function. If I want to modify that outer password, I have to use what's called global statement. And then I need to tell it I want to pull in my password. What that allows me to do is then edit the global password on the outside, and I can change it at will. All right. This is important because this is one of the #1 questions students miss on the midterm. So if I want to be able to modify a global variable, I have to use the global statement, and I must specify which global variable I'm wanting to edit. If I just say global, nothing happens. All right. Hint, hint, wink, wink. This is the #1 question missed on the midterm. Anybody got any questions on local and global scopes? Practice with it, play with it, go do some of these extras that you're going to see down here at the bottom. It will help you understand local and global scope. It is a strong place where students get confused as to why it's not working like they expected. All right. If we have more than one function up here at the top, for example, we have def something else, and I set a variable here called my password equals Sam. This my password and this my password are completely different because this is a local variable inside the function. This is a local variable inside this function. I cannot reference across functions and try to pull in passwords. I would have to define that as a global variable. Then I could pull it into my individual functions and modify it there. All right. So if I set variable names that are inside of this function, I cannot access them inside of another function. Unless I pass that into the function, in which case I could. So for example, if I have this, my password is Sam, and I now call calculate password is now my password. Now I'm passing this one into this function, in which case I can modify it. But because I'm specifying my password up here, notice I'm getting into a really nasty mess. And this is why it's important to name your variables appropriately for both functions as well as global variables. If you start reusing the same names over and over, it gets really confusing really, really fast. Did I lose everybody on this local global thing? If so, tell me, because otherwise I have to assume that you get it. All right. As I mentioned down here, this is all just going to talk about the same thing that I had before. Again, if you had local variables and global variables that end up having the same name, the local variable will override inside the function, meaning that it's going to be the same one. While it's technically acceptable in Python to do that, I strongly encourage you to keep your variables in different names. All right. We talked about the global statement. All right. So now down here at the bottom, we typically have been seeing a lot of errors when we try to run code, right? So if we go back here and look at this code I was running before, we get area variables or errors such as this one here, right? And if we look at this type of error, we're told here that this is an unbound local error. In this case, we tried to use my password before it was defined. All right, remember, Python has to go in order. If we want to error on a specific type of error, we can use different error or exception warnings to get those back, right? So in this example, they're showing here, return 42 divided by 2 or 12 or 0. At this point, it's going to fail, right? We can't divide 42 by 0, which means that we will get a 0 division error and see that inside of here. What we can use is what's called a try clause and an except clause. What this would allow us to do is to try to do something, for example, this, and if we find that there is an error, in this case, specifically a 0 division error, we can print that error and continue on, all right? Where is this useful for you guys? This is how we're going to be able to finally sanitize the input we get out from the users. So if we go away from all of this, then we say print hello and welcome to my program, right? We can say print what is your age. We gather their age. You guys might remember this that we've done so far. Then we want to do something with that age, right? Say we want to add 10 to it. Well, if we just say int age plus 10, and we say this is our new age, right? And then we print new age. We can run this simple program. We type in 42. Everything works as expected, right? But when that user types in gibberish, we end up getting an error. And in this case, it's a value error. We cannot take ASDF, convert that to a number, and add 10, right? So what we want to do is put a try statement here. And we're going to try to convert this over and add 10. And if we get an exception, in this case, we're going to accept on value error. Then we can say print that is not a valid age. Please try again. We can now put this inside of a while loop. In which case, if this is correct, we can go ahead and break. And if it's not correct, we're going to keep them in the loop and go over and over. So now if I run this and I type in ASDF, I'm going to get an error back as opposed to just breaking the program. So from here on out, on your guys' homework assignments, your midterm projects, etc., you now have a way of checking that you're going to try to run code. And if it doesn't work, you have this exception where you can print something out and make the user type in something that's correct. This is called sanitizing your inputs. So if you see that message coming from me, that means, hey, no longer can we accept gibberish from the user. We only accept what we expected that to come in as. All right. We may have other checks in here, in which case we may do an if check to make sure that this is greater than 0, right? You can't be negative in age. And we might say that, you know, over 110, that's probably not a valid age, or 120. So always do something to check your inputs. Expect a 3-year-old to come in and type gibberish into your program. Is it going to break your program? Because if I start seeing these reds, then I start counting off from here on out. All right. The best way to use this one is like when you're converting something where you're expecting them to type in a number and you can't tell until you try to convert that over to an integer. If this part doesn't work, it immediately does an exception. Now, there is a catch-all, meaning that I don't have to specify value error. If there is any error coming out, I can go ahead and just run this print statement. All right, so usually just try and accept. But if you want to accept on a specific error, you can do that. If there's an option for them to have multiple errors, you could do that down here, and you could accept on different type of errors. See, I got a question come in. Let's see. All right, Dave, did you have any specific question?
No, I'm just going to have to go through and probably reread it a little bit and look at the recordings. It went pretty fast, but it's fine.
Yeah, I do feel like it went fast. I won't argue. That definitely felt like it went fast. So how do you start to understand this kind of thing? I encourage you to come down here and always do these programs that are down at the bottom of the homework assignment, right? They'll have practice questions, and then they're going to have these practice projects. If you can get through the practice projects, that means that you understood the assignment as a whole, right? So for example, if this one, we want to do input validation, AKA sanitize our inputs. We can add try and accept statements to this previous project to detect whether the user types in a non-integer string, which is what I just showed you. And normally that int function will raise a value error if it's passed in a non-integer string, and we could use an except clause to print that out, all right? So if you go back to your homework assignment 1 and homework assignment 2, where you're asking for an age or some kind of number, right? Because you were supposed to use a math operator. Now try to add these try and accept statements and try to type in gibberish. And if gibberish, it should return them back to type in something else. That's a great way of practicing try and accept statements. Again, from here on out, your homework assignments, your midterm projects, etc., I will intentionally try to break your program. If I can break your program and it crashes to red, you lose points. Right? Always try to check your code and only let the user type in the valid input that should be inside of there. When it comes to functions, remember that functions should always be defined at the top of your program. So the order in which you would define things, you would always start with your initial comments. Right, so this might be INF360, etc. JSON, assignment 3, whatever it is. You are then going to have generally a description of what this project is. For your midterm project is where that assignment starts coming in. So you'll say something like, this is my midterm project. And you would actually describe what the project is. Note, I'm using 3 double quotes here. We'll talk about that a little bit more later. This is just a way to do multi-line strings without having to use the hashtag up above. So hashtag is meant for a single inline comment. This is meant for a multi-line comment, meaning that I can have multiple statements inside of here. All of that is a comment inside of those 3 hashtags. So then I can format the way I want it. This will never get printed out. It's just an block comment is what it's referred to as. After the block comment, this is where I'll have my imports. So I'll have something like random, or maybe I'm importing sys for my project. And then I'm going to have all of my functions defined immediately below that. So def hello, print ASDF. Inside of there, I may have multiple functions inside of here. I print all of those. Then I start down here with saying main code down below. If you get in the habit of formatting it in this structure, you will always have it in the right way. You'll also remember that this print statement is the first line of code that truly gets executed in our program. We're going to try to import a few things. If that doesn't work, then it may fail up here. So if for some reason it can't find the random module, that would fail. In which case we would wrap this import in a try and accept statement. We'll talk about that much later on when we start dealing with third-party modules. All right, try and accept is your friend. You're going to try some code. If it doesn't work, we're going to accept on it, throw some kind of error that's meaningful to the user, and try it all over again. Definitely practice local variables and global variables. Just write silly programs just to understand the two and how you would override one and the other. The key to all of that is naming things differently between your global variables and your local variables. call it something else. If you need to modify the global variable, what do we have to put inside of our function? Has to go at the very top of the function. Does anybody remember? If I want to modify a global variable that was down here, for example, age, what do I have to type inside my function? Global age, right? So I have to have my global statement, and I need to tell it what variable I want to bring into this function. At that point, I can modify this variable on the outside. If I don't have this and I just say age equals 3, I am not modifying this age on the outside. I'm now defining this age that is a local variable only within my function. At the very end of this function, that variable disappears and goes away. I cannot reuse it. I cannot recall it. All right. Again, the main reason for using functions is to reduce or deduplicate your code. So if you're noticing that you're doing the same thing over and over and over in your code, that can probably be written into as a function, where we can call that function and save us 20, 30, 40, hundreds of lines of code just by using a simple function. Another reason for using functions is to break up your code into individual parts. So if we have a introduction or a welcome, right, we could do def welcome. We put everything we want at the start of our program, like say a main menu or whatever it is, that should go inside the welcome function. And if we need to call that again, we just simply call the welcome function. All right. If I want to gather your name and your age, but we want you to have an option to change that age, then I should probably put the code that's relative to getting your age into a function, so I can just call that code again and not have to redo the code again inside my main program. In your midterm project, you guys are required to have a function and multiple functions inside your midterm project, right? That's the number one thing students miss. They start writing out code like it's homework assignment 1 and 2. I need you to demonstrate functions inside of there. So they may be small functions, and I don't want to see functions that just do print statements, right? It should do some form of a calculation, modification, something. It can print out after that, but it needs to do something more than call it hello, and then we print hello 3 times. That isn't a good use of a function, all right? You're either using functions to deduce code or to segregate your code into bits and pieces. That segregation part is going to become handy because as your programs get longer and longer and longer, for example, your midterm projects, it makes sense to have multiple functions. That way, if I know something's wrong with the code that gathers my age, I just go look at the age function. Whatever's gathering that code, I can just go edit that one thing. I don't have to scroll through every single time I had code for gathering age. You will get lost. You'll fix it in one place and forgot you need to fix it in 5 other places. Put it in a function, modify it one time. All right, anybody got any questions? Okay, real quick, since we're at the end of this and we still got some time, we're going to go back through real quick chapter 0. Does anybody remember what we learned in chapter 0? It told us what? What class are you in? It's not a trick question. You're in Python, right? So you guys are learning what programming language? Python, right? And wink, wink. Know that for the quiz. It's a real tough question, all right? Yes, students miss that question. They're probably falling asleep. All right. Chapter 1, we learned about math operators. Remember the order of precedence, meaning that exponents have a higher precedence than addition, right? This goes from the top down in order of precedence. You should know which one would get evaluated before the one below it, all right? This will be on the quiz. So know your order of operations. We talked about the assignment statement. Assignment statements, we use a single equal sign. Variable names, know what's valid and what's not valid, AKA know this table. Pretty simple. Inside your first program, we talked about opening. We talked about the print function. We also learned today that the print function can have 2 extra arguments. Does anybody remember what those are? If I want to change the ending of my print function, I would modify the what variable? End, right? And if I want to change what separates when I print multiple things together, I would change which variable? Set variable, right? I know these all sound super tricky. They're really not, but it's easy to get tripped up on this stuff. So if I wanted to change the ending for a print string, I would set the end. If I want to set the separator between being multiple things being printed, I would use the set variable. All right. You guys learned the input function. You also learned the len function, which will calculate the length of something. This will come in extremely handy starting next week when we start dealing with lists and dictionaries and ways of storing data more than just one variable inside of it. Right. You also learned the 3 functions of string, integer, and float. This allows you to convert things back and forth. Can I convert strings into integers? Is it possible to convert strings into integers? Yes, it's possible. Under which condition? Has to be a number, right? There could be no letters or characters other than numbers inside of there. Can I convert an integer to a float? Can I convert a float into an integer? Can I convert floats into integers into strings? Is there any case where I could not convert an integer and float to a string? The answer is no. String is universal, meaning that I can convert any integer and float into a string at any point in time, right? These could all be numbers. These could be, obviously, they have to be numbers. They're integers and floats. But I can always convert those into string. I cannot always convert integers and floats into strings, right? They have to be numbers in order for that to work. So string is usually considered the universal variable type, or data type. All right. Let's see here. That sums up chapter 1. Let's look real quick at chapter 2. Know your comparison operators, what they mean. Know the difference between a single equal sign and a double equal sign. Remember, a double equal sign is the equivalent of equal to. A single equal sign is an assignment operator. We're telling it what it is. All right. Know your Boolean truth tables, knowing that true and true is false, etc., depending on whether you use and or not. In your if-else conditions, note how those work and the variable requirements. Am I required to have an if statement if I want an if-else? Yes, right? If I don't have an if, then I can't start an if-else statement. Is it required that I have an elif? No. Is it required that I have an else? No. Can I put an else before an elif? No. All right. Simple little things like that is what you're going to need to know for that quiz. In while loops, it's going to go on indefinite. How can I get out of a while loop? Break, right? If I want that while loop to start over, I could use a continue. All right. For loops, what's the difference between a for loop and a while loop? A for loop typically has a finite number of times you're going to be looping through it, right? So if I'm using this range function and I say 1 to 5, that gives me what numbers? 4, right? 1, 2, 3, 4, right? I would not have 5, so it goes up to 5, but does not include 5. When I use a random integer or a random number and I say 1 to 5, what numbers would I get back? 1 through 5, right? Random integer, it goes up to and includes that last number. Know the difference between the two of those. That will be on the quiz as well. right? Remember, for loops always have a finite number. A while loop is only going to go until a condition's met, which means it may go infinite number of times until that condition is met. All right, in the range section, note that this first number is where we start. The second number is where we stop. There is a third number, such as this 2, in which case we will increment by that, and that's called the stepping number. All right, or the stepping argument. You should know that. That's going to be on the quiz and even the midterm. All right. Then last but not least, today we talked about functions and building out functions. If I have this function up here called hello, and in this code, would I ever get ASDF to print in this code that I wrote down here? Would I ever see this line get executed? And why not? What's that? No. Would this line of code here ever get executed? You got it. The reason this would never get printed out is because I never called the hello function in my code, right? So I can have 40 different functions up here, but if I never call them, that line of code is never going to get executed. Know that for the quiz. All right. Know your global and variables that we talked about today. Know the endings for your print functions. All right. Anybody got any questions on what could be on the quiz or any other things from this week? All right. Now that we reviewed, guess what Wednesday is? It's a free day. You can show up here and do your quiz, or you can do it at home, or you can do it anytime before Sunday. AKA no class Wednesday, right? We did our review here, know what the new variables are, study, practice that stuff on Wednesday, but you don't have to physically be here. And we won't have a WebEx session on Wednesday, all right? All right, if you have questions, email me, send me to the office. I know a bunch of you guys emailed me over the weekend. I will get back up on those emails. I will get all the rest of those assignments graded and out to you today. All right, thank you.